Hello students, how are you all? Welcome back to the lecture number 7 of current and electricity. Alright, so today we're going to learn what is battery or cell and how does it actually work. We use 1.5 volt, 9 volt battery in our household things and also 12 volt battery in our cars. So let's check out how does it work. Okay, so in this container I got some H2SO4, sulfuric acid, where you putting two rods, metallic rod obviously, one is zinc, another is copper. Now by redox reaction, according to the chemical reactions, we are getting negatively charged zinc rod and positively charged copper rod, and those are now known as cathode as positive one, anode as negative one. So why this one is negative? Because this containing so much of electrons. And why this one is positive? Because the cell, that means the mechanism of that cell is taking out the electron from here and moving it in the zinc plate. So here the plate facing a vacancy of electron, while the zinc plate facing more electrons are there. Okay. So while you are connecting the circuit with this mechanism, you are getting the flow of electron due to potential difference. Okay. So while the electrons are flowing through it, we know that we will get the current in the opposite direction. So we are getting I current in the opposite direction. Now that what we actually know. But what is the main thing in here? What we should know from here? That the electrons are moving from here to here. Again, while the electrons are coming in this positive cathode rod, it is again by the mechanism of battery taking out from here. And again we are moving that electron from this positive plate to negative plate. And that is how we completing the whole circuit. Okay. Now coming to the definition of EMF. EMF means electromotive force, but remember that it is not a force, it is only energy per charge. Okay, so to move one positive charge or one electron or a test charge. So I will say, according to the mechanism, to move an electron in a complete circuit, that means you are completing this circulation. The energy required is known as the EMF of this mechanism, that is known as cell. So this is the formula of the EMF, while EMF is the energy by the charge. I am writing work done instead of energy because we know that the work done is nothing but energy itself. Okay, so what should be its SI unit? That is joule per coulomb, as we got joule for the SI unit of work or energy, and the SI unit of charge, we know that it is coulomb. So let's move on to another one. Alright, so in this mechanism we know that we already learned the potential difference or terminal voltage. The terminal voltage is actually nothing but the potential difference. So what we know about potential difference? If you measure these two terminals, one positive, one negative, if you measure the potential difference between two terminals, you actually get the voltage of a cell, and that is known as terminal voltage. If I clear it more specifically, that terminal voltage is give you the energy required to move one electron from here to here. But what about this one? This is actually known as the voltage drop. While you moving that electron from this positive cathode to this negative anode, from this electrolyte in that solution, that energy is known as the voltage drop. So I told you earlier that the total circulation, the energy required for the total circulation is known as EMF of cell, and that should be equal to the summation of both. One energy you are moving from here to here, another energy you are moving from here to here, and if you add those two energies, you will get the total energy as EMF. So this is the relation between terminal voltage and EMF of cell. And also remember that the terminal voltage is less than the EMF of cell. Okay, So that's all for today. Don't forget to like, share and subscribe, and tab tak ke liye goodbye.